Wayne Gretzky once said, "A good hockey player plays where the puck is. A great hockey player plays where the puck is going to be." What did he mean by this? He meant that intercepting a target is the fastest way to capture it. And this is a great strategy. But it may be easier said than done, especially if you're not sure where the puck is going. Hockey players aren't the only ones that are worried about this problem. Baseball players have to chase down fly balls, and the military spends billions of dollars on missile interception systems. But we can also look to nature for examples. Animals that actively hunt prey have to solve this hockey puck problem every single day. So, what's the best targeting strategy for predators? The answer isn't simple. An animal may choose a different strategy based on a different type of prey, or it may have a single strategy simply because there's no alternative. This may be due to physical limits of its body or limits imposed on it by its environment. There are many predator-prey systems in nature that we can study. Each has its own setting, characters, and plot. I'm fascinated by a voracious swimming predator that hunts in freshwater streams, the zebrafish. Now, does the zebrafish simply chase down its prey until it's close enough to bite? Or does it swim on a collision course to where the prey will be? And how important is vision during all of this? You might be wondering, why the zebrafish? This fish is native to inland streams and rivers of India, but now it can be found all over the world, mostly in aquariums and research labs. You may be familiar with the term lab rat. Well, the zebrafish is the lab rat for many scientists, which means that a lot of effort and money has been devoted to studying the small fish. So what makes this striped 3-centimeter long fish so special? Well, it's special to me because I can see right through it. And I don't mean that figuratively. I can literally see through its body. This allows me to see its retina, which is the light-sensitive part of the eye. Another awesome feature is that baby zebrafish will begin hunting just a couple of days after they hatch. If you have ever been to a new city, you've likely used some kind of map to find your way around. Once you figured out where to go, you check the map and you start your adventure. You walk for a little while and then you check the map again, just to make sure you're on the right track. This is very similar to the way the zebrafish swims. It figures out where to go, beats its tail, and glides. Takes a look around, and continues. While it's gliding, it's able to take in the scene and hopefully locate its prey. To figure out how well the predator targets its prey, I record adult zebrafish as they hunt younger fish. Yep, they'll eat their own kind. And it may be shocking to us, but it's a behavior found commonly in the animal kingdom. So I use high-speed video cameras to record these predatory interactions at 500 frames per second or faster, which is quite an improvement over conventional cameras, which only clock in at about 30 frames per second. Then I analyze the videos frame by frame to gain a detailed understanding of every subtle move. One of the things that I measure is called the bearing angle. This describes how well the predator aims at its target. And I've determined that the zebrafish has a very good sense for this angle. And it uses this information so that it can make turns to point directly at its prey. The question then is, how does it know this angle? What information is it using to control how much it should turn? My intuition and the many hours I spent watching fish fights tells me that there's a particular visual cue that tells a predator when to turn and by how much. Since I can see their retina, I have a pretty good sense for what they can see. Using this information, I'll be able to figure out what that particular visual cue is. And in a few years, we will understand how zebrafish maneuver to capture their prey and the role that vision plays in this behavior. Now, my lab rat, the zebrafish, may not be a great hockey player, but it works with what it has, captures enough prey to ensure its own survival, and it gives us a nugget of insight into how visual information is translated into useful behavior. Thank you.